Hey everybody, this video is about how to know what formula to use to solve kinematics equations, and there are some steps that need to be followed. Even for these simple ones, if you get in a good habit, it's going to pay off later. These are the main steps that you want to follow. You want to decide if the motion is acceleration or constant velocity, and there are some clues that help you decide that, and I can talk you through that. Also, you want to draw a simple sketch. What we're talking about is like if it's a bike and you can't draw a bike, you draw a box or you draw a point for a person. Super simple sketch that gets you oriented to what's happening in the problem. C, list the variables. So we make a distinct list with the variables all listed vertically, and D, choose a formula that has all the variables you have and the one that you're solving for as well. So even if something's missing, you put it in your list. Then once you've chosen your formula and you've written it out, you substitute into the formula and then you solve and you label. So, for example, here's our example problem. A student on a bike is going 12 meters per second and then rolls up a hill, eventually coming to a stop. If they stop in 4 seconds, what is their acceleration? So you have some definite clues listed here, but the first thing we want to do is decide if the motion is acceleration or constant velocity. So the main clue is that it's saying what is the acceleration. So obviously this object is going from a velocity of 12 and then it is stopping, so it has changed velocity. So if there is change in the velocity, then you're going to want to use the acceleration formulas. If not, then you consider constant velocity. So if something moves at a constant velocity, it doesn't change at all. It's always going the same velocity. Second thing, you want to draw a simple sketch of the equation or of the situation. So if there's somebody on a bike and then they go uphill, and let's say I can't draw a bike, but I can draw 2 circles that sort of look like a bike, that's good enough. So what I would say is right here, the person is going 12 meters per second, and right here, the person has stopped. So I draw that out so that I get an idea. If I want to add like a motion map, I can add a motion map too. But that's what I mean by drawing the situation. C, list the variables. So the variables that we have here, a student on a bike is going 12 meters per second. So that's V initial. So V initial equals 12 meters per second. So I write that out. Right under that, I keep listing my variables. Eventually coming to a stop. So eventually, meaning at the end, they come to a stop. So that's the final velocity, which is 0 meters per second. I'm listing my labels as well. If they stop in 4 seconds, so seconds is measuring time, so time equals 4 seconds, and we say what is their acceleration? So A equals, we don't know what. So this gets us to A, B, and C. So now we need to choose the formula that has all the variables that you have in the one that you're solving for. So we're looking for a formula that has V, VO, T, and A, and I think when I switch screens I'm going to lose my writing here, but that's okay. So let's take a look. So if I pick from these formulas right here, I'm going to have all of these as the acceleration formulas, and I'm going to have these as our constant velocity formulas. So before we had VO, we had V, which is the same as V final, we had A, and we had T. And so our listing, VF was equal to 0, VO was equal to 12 meters per second, A we didn't know what, and T was equal to 4 seconds. So we have all 4 of those. How do we know which one to choose? We have to choose this one because it has everything we have and nothing that we don't. All the other ones have X. These are actually just the same. This has X, and this also has X. So we know that we need to do V final equals V initial plus AT. Oops, I just rearranged those, put those in different order, wouldn't change your outcome. So my V final is 0 equals VO is 12 meters per second plus A, which we don't know, times T, which is 4 seconds. So then I go about solving that, and I would get negative 12 on this side equals a times 4 seconds. I'm going to divide both sides by 4 seconds. And I'm going to get a equal to -3 meters per second per second. So that would be my acceleration. Sometimes you'll see that as -3 meters per second squared. So that is my solution. And these other parts, this is choosing the formula. This is called substituting this part, and I always write it right below my formula. This is the solving, this is where your algebra comes in, and this is your label. Now, one of the best things about this is that when you label in your work, like meters per second and seconds, when I go to divide these out, that goes away, what do I have for a label? Meters per second per second. And because I have been diligent in using my labels in the problem, it also works out that I have a label at the end. So that's how you know how to solve a kinematics problem. Some of them are going to be harder, some of them are going to be easier. You look for the clue that if nothing changes, everything stays the same, then you're going to use the constant velocity equations. If you have change in motion, then you're going to use the uniform acceleration ones. So that's how you do that, and that should